Hi, this is Mary Faith Navarro from BSIS Set 1A. So I'm going to discuss about the mathematics of graphs from Module 4. So, elements of graph theory. First, identify the vertices, edges, and loops of a graph. Identify the degree of a vertex. Identify and draw both a path and a circuit through a graph. Determine whether a graph is connected or disconnected. Find the shortest path through a graph using Dijkstra's algorithm. So first, what is graph? A graph consists of a set of dots called vertices and a set of edges connecting pairs of vertices. So this is the example of graphs. So Leonhard Euler, one of the most prolific mathematicians ever, looked at this problem in 1735, laying the foundation for graph theory as a field in mathematics. This one. To analyze this problem, Euler introduced edges representing the bridges. So this picture is connected to each other. North bank to island to south bank to east bank, and they are connected to itself. The vertices are connected to itself. Since the size of each land mass, it is not relevant to the question of bridge crossings. Each can be shrunk down to a vertex representing the location. This one. So they shrunk down to a vertex. So the NB represents the acronym of North Bank. The I is the island, the SB is the South Bank, and the EB is the East Bank. Notice that in this graph, there are two edges connecting the North Bank and island, corresponding to the two bridges in the original drawing. Depending upon the interpretation of edges and vertices appropriate to a scenario, it is entirely possible and reasonable to have more than one edge connecting two vertices. So while we haven't answered the actual question yet of whether or not there is a route which crosses every bridge once and returns to the starting location, the graph provides the foundation for exploring this question. So we must first define some terminology. So let's try to be more specific now. So number 1. So what is vertex? A vertex is a dot in the graph that could represent an intersection of streets, a landmass, or a general location like work or school. Vertices are often connected by edges. Note that vertices only occur when a dot is explicitly placed, not whenever two edges cross. So, imagine a freeway overpass. The freeway and side street cross, but it is not possible to change from the side street to the freeway at that point. So at that point, so there is no intersection and no vertex would be placed. So vertex is the dot in the graph. So next is edges. What is edges? Edges connect pairs of vertices. So the edges is the line. An edge can represent a physical connection between locations, like a street, as simply that a route connecting the two locations exists, like an airline flight. So those the edges are those lines that attach in the vertex. Next is loop. What is loop? Loop is a special type of edge that connects a vertex to itself. Loops are not used much in street network graphs. So, as you can see the picture in the right side, this is the example of a loop. This is a graph that is a loop. So as you can see, they are connected to itself. So that is an example of loop. Next is, what is degree of a vertex? The degree of a vertex is the number of edges meeting at that vertex. Degree of a vertex is the number of the edges, which is the line, meeting at that vertex, which is the dot in the graph. So for example, in the picture in the left side, as you can see, there is a graph, and the dots or the circles, which is the vertices or vertex, represents there are V1, V2, V3, and V4. That means vertex 1, vertex 2, vertex 3, and vertex 4. So as you can see, in vertex 1, there are two edges that is connected to him. It's connected to vertex 1. So it means the degree of a vertex, the degree of the vertex 1 is 2 because it has two edges connected to him. The edges is the line. So it is possible for a vertex to have a degree of 0 or larger. So as you can see in the graph, the vertex 2, the vertex 2, he has only one edge. So it means the degree of vertex 2 is 1 because he has only one edge, which is edge means the line connected to the vertex. So next is, if the dot, which is the vertex, has one line, means the degree of the vertex is 1. If the dot, which is the vertex with two line attached to it, means the degree of a vertex is 2. If a dot, which is the vertex, has 3 lines attached to it, means the degree of the vertex is 3. So what is path? Path is a sequence of vertices using the edges. Usually we are interested in a path between two vertices. So as you can see in the picture in the right side, the highlighted red line, that is the path from vertex A to vertex M. So next is the circuit. A circuit is a path that begins and ends at the same vertex. So the difference between the path and circuit is that path it does not repeat to the vertex itself. Circuit is a path but it does repeat in the same vertex. Like example in the picture below, the graph starts with vertex A and also ends with the same vertex, which is the vertex A. It begins with vertex A and it also ends with vertex A. So that is a circuit. Next, connected. A graph is connected if there is a path from any vertex to any other vertex. So every graph drawn so far has been connected. The graph in the right side is disconnected. There is no way to get from the vertices on the left to the vertices on the right. So next is weights. Depending upon the problem being solved, sometimes weights are assigned to the edges. The weights could represent the distance between two locations, the travel time, or the travel cost. So next. So our goal in this chapter is to develop methods to solve complex problems in a systematic way and to find the shortest path in the graph by following algorithms by Dijkstra. So what is algorithm, by the way? Algorithm is a step-by-step procedure for solving a problem. So Dijkstra's algorithm will find the shortest path between two vertices. So here is the Dijkstra's algorithm. First, step 1, mark the ending vertex with a distance of 0. Designate this vertex as current. Step 2, find all vertices leading to the current vertex. Calculate their distances to the end. Step 3, mark the current vertex as visited. Step 4, mark the vertex with the smallest distance as current and repeat from step 2. So, example. So the picture is a graph. As you can see, the question below, what is the shortest path to travel from A to Z? So we're going to find the shortest path between vertices between A to Z. To find the shortest way, we're going to calculate those numbers that represents the edges to find short the shortest way to go to Z. So this one. Sample. More than 5 ways to vertex A to Z. First one. So A, B, D, and Z. We're going to calculate the numbers represented in the edges from from vertex A to Z. So as you can see, the vertex A to B, the edges that is 4. Then from B to D is 5. Then from D to Z is 6. So add it all. So the result is 15. So remember that we're trying different paths just to find the shortest one, the smallest number of result. I'm trying different paths. There's also a path that from A from A to C to E and to Z, then another one, the third one from vertex A to B to C to E and to Z, then the fourth one from A to C to D and to Z. But the number got higher or got bigger. So the last one of the fifth, I found the shortest path, the shortest way to go to Z, which is vertex A to C to B to D and to Z. So as you can see, the number of edges represent from vertex A to C is 2. Then C to B is 1. Then B to D is 5. And then D to Z is 6. And I added it and it results to 14. Among the five there, among the 5 different paths from vertex A to Z, 14 the 14 number is the only smallest among them, the smallest edges among them. So it means that is the shortest path from vertex A to Z. Next, we're done in that. So another example, but we're not going to find the shortest path. We're going to determine how many vertex. So as you can see in the graph, in the left side, it represents the vertex A to vertex B to vertex C to vertex D, then to vertex A again, and to vertex E. So going to determine how many vertex all in all in the graph. We're going to count the vertex. See, it has 5 vertex. It has 5 vertex. So remember that vertex is the circle one or the dot represented by the letters. So next is edges. So remember that edges is the line attached to the vertex. As you can see, it has 5 edges. 5 edges or 5 lines. The next is we're going to find the degree of vertex of C. Remember that finding the degree of a vertex is counting of how many edges attached to the vertex or number of edges. So to find the degree of vertex again is to count the number of edges attached to the vertex. So try to find the degree of a vertex of letter C. So as you can see in the vertex C or the dot, it has two lines or two edges attached to it. So it means it has 2 degree of a vertex. In the graph, where is the path there? So when we are going to highlight the vertex C to D to A and to E, that is called path. So next is circuit. Circuit again is a path also that begins and ends at the same vertex. So in the graph there, if we're going to highlight from A to D to C, then to B, and ends to A, vertex A. So that can be a circuit. That can be called a circuit because it starts with vertex A and it also ends with vertex A. And yeah, and yes, they are connected to itself. So that's all for the discussion, and thank you.